Okay, my task is to graph f of x equals the opposite of the square root of x, is what that says. The opposite is on the outside. So here what I'm doing is taking the opposite of the outputs. It's not of the inputs. If I meant to take the opposite of the inputs, then I put the negative on the x, not on the outside of the function. The parent function is the square root of x. The negative is in front of that parent, the opposite of the square root of x. So I'm going to take the opposite of my outputs. I have my parent function graphed above with its 3 key points. 0 gives you 0, the square root of 1 is 1, and the square root of 4 is 2. So I'm going to take the opposite of the outputs. So let me just write that in a table. There's x comma y when y is here, and that's 0, 0, 1, 1, 4, 2. Now I'm taking the opposite of those outputs. So the opposite of 0, 0, the opposite of 1 is negative 1, the opposite of 2 is negative 2. So these are the points I'm going to plot: 0, 0, 1, negative 1, 4, negative 2, because I'm trying to plot f of x. And when I do that, I end up with this graph. It is, in words, the graph of the parent function reflected over the horizontal axis. So an opposite on the output is going to have you reflect over the horizontal axis. Now, number 2 is very different. To start with, it's a different parent function. Then it's subtract 3, and the subtract 3 is on the input. It says take 3 away from the input, but remember that x transformations are counterintuitive. So if we're changing the input, the x value, what we really mean here is we're going to need to add 3 to the inputs to get the same output. And the parent graph looks like this. 0 gives you 0, 1 gives you 1 output, 2 gives you 4 output, and negative 2 gives you 4 output, and negative 1 gives you 1 output. So the outputs are going to all stay the same, but the inputs now, I'm going to add 3 to them. So just to put that in a table format, my x comma y looks like negative 2 gives me 4, negative 1 gives me 1, 0 gives me 1, 0 gives me 0, 1 gives me 1, 2 gives me 4. It's the inputs that are changing. The outputs will stay the same. I'm going to add 3 to the inputs. So I'm going to have 1 here, add 3, 2, add 3, 3, add 3, 4, add 3, 5. These are the inputs that I'm going to graph with the outputs that I circled next to it. Double check that you believe it, okay? For the function, which was given as g of x, I think. When I input 1, 1 minus 3, oh, it was squared too. When I input 1, 1 minus 3 is negative 2, negative 2 squared is 4. When I input 2, 2 minus 3 is negative 1, negative 1 squared is 1. When I input 3, 3 minus 3 is 0, 0 squared is 0. When I input 4, 4 minus 3 is 1, 1 squared is 1. When I input 5, 5 minus 3 is 2, and 2 squared is 4. So these ordered pairs are correct. I need to add 3 to the inputs to get the same output. So 1 gives me 1, 2, 3, 4. 2 gives me 1. 3, 0, 4, 1, 5, back up at 4. And what I see here is the graph of the parent graph shifted right 3. Number 3, I have the parent graph written above, graphed above. The cube root of 1 is 1. The cube root of 8 is 2. And the cube root of negative 1 is negative 1. That's that key point. And the cube root of negative 8 is negative 2. That's that key point. So these are the key points on the cube root graph. And what this says to do is to divide 3 by the outputs. Outputs divided by 3. That is not counterintuitive. That's literally take the outputs, whatever they are, these y values, and make them a third as long as they were. Divide them by 3. So 0 divided by 3 is still 0. The output of 1 right here, I would divide that by 3. So now that's only 1/3. 1 is only 1/3. 8 is now 2/3. Not even 1 yet. -1, -1/3. And -8, -2/3. What does this do to the graph? It essentially compresses it. No, it compresses it towards the x-axis, the horizontal axis, by a factor of 3. That's what's happening here when we divide the outputs by 3, the y values by 3. Number 4, my parent graph for 1 over x, 1 gives you 1, but 1/2 gives you 2, and 2 gives you 1/2. There's your key points for the parent graph, y equals 1 over x, and then it has origin symmetry, so we're going to see a repeat in quadrant 3. That's the parent graph. This is a counterintuitive x transformation. The input, we need to subtract 5. I know it says add, but remember that x transformations are counterintuitive. So that means instead of moving right, we're going to move this left 5. The thing you want to pick up and move left 5 is this asymptote. It's called an asymptote, but really what it's like is a guideline. Pick that up and move it left 5, and then move all the key points left 5. 1, 2, 3, 4, 5. Show the guideline dotted, then up 1 over 1 at that guideline to sketch your 1 over x graph, and left 1, down 1 to sketch the other part of it. And that is the graph shifted left 5, the parent graph of 1 over x left 5. For J, this says divide the x values by 4, but that's counterintuitive. You want to multiply the inputs by 4. Any x transformations work backwards the way you think they would. They're counterintuitive. We want to multiply the inputs by 4. Our parent, y equals the absolute value of x. The absolute value of 1 is 1, the absolute value of 0 is 0, the absolute value of -1 is +1 also. Those 3 points, key points. So what I'm saying is you multiply the inputs, 1 and -1 are inputs, by 4. You do not change the outputs, the y values. They stay the same. They're going to be 1 and 0. So 1, 2, 3, 4, still 1. 0 multiplied by 4 is still 0. -1 multiplied by 4 is -4. But the outputs don't change. Now, I know this looks like it might be a vertical compression, but it isn't. Because we're multiplying the inputs by 4, what we're doing, since we're multiplying, is we're stretching the graph away from the y-axis, the vertical axis, by a factor of 4. It might look more like compressing vertically, but it definitely is stretching if we're talking about multiplying the inputs by 4. That's the graph of j of x. For number 6, our parent graph, y equals x cubed. 1 cubed is 1, 2 cubed is all the way up to 8. 0 cubed is 0, -1 cubed is -1, and -2 cubed is -8. So that's our parent graph with its 1, 2, 3, 4, 5 key points. Now, what's going on here? Should I get my yellow highlighter marker or my blue? I'm choosing yellow because I'm taking the parent graph right here, the output of it, and subtracting 1. This is outputs minus 1. It is not counterintuitive when you do an output transformation. It's very intuitive. It says take 1 away from the outputs. So that means that I'm in effect going to shift the graph down 1. Because this output's going to change down, this output's going to change down, this output's going to change down, that one down, and that one down. I can make a table of values if I want. 0 would now be -1, 1 would now be at 0, 2 would now be at 7, -1 would now be at -2, and -2 would now be at -9. That is the graph of Q. This one here, I have my parent graph that I have graphed above, this one right here. And since it's +2 after the parent graph, y equals 1 over x, and then it says +2, that's add 2 to the outputs, to the y values, add 2. Do not change the x's, but add 2 to the y's. So that's going to shift this graph up 2. This time I'm going to take this guideline right here and move it up 2. So from my parent graph, I take the x-axis up 2. The guideline that is vertical doesn't change at all because I'm not shifting that right or left. And then on that little new coordinate system, I'm going to go up 1 over 1 and left 1, down 1 for my key points and sketch my 1 over x graph. This should be using it as a guideline. So I'm shifting that guideline, or it's called an asymptote, up 2. Number 8, the minus is on the input. That means I'm taking the opposite of the inputs. So your normal square root graph looks like this. 0 gives you 0, 1 gives you 1, 4 gives you 2, right? It goes 0 gives you 0, 1 gives you 1, 4 gives you 2. But now I want to take the opposite of the outputs. So the opposite of 0 is 0, the opposite of 1 is -1, and the opposite of 4 is -4. So now I'm plotting the point 0, 0, -1, 1, -4, 2. If I sketch a graph of that, 0, 0, -1, 1, -4, 2. What I see is that I've taken the parent and reflected over the y-axis, the vertical axis. So an opposite on the x will reflect over the y, and an opposite on the y, back up here to this problem, will reflect over the x-axis. It's just important to note, is it the input or the output that's doing the changing? That's really the easiest way to do these problems. On number 9, I am changing the output. So I'm going to use my yellow highlighter here. Not counterintuitive. I'm going to multiply the outputs, or the y values, by 5. So I'm going to take my cube root graph, and I'll show that in black. 0 gives you 0, 1 gives you 1, 8 gives you 2, right? And -1 gives you -1, and -8 gives you -2. I'm taking that parent graph, and then I will sketch the transformed graph in red, P, okay? So that's the parent. I want to multiply the outputs by 5. 0 times 0 is still 0, The output here is 1. I'm going to multiply that by 5. It'll now be up here at 5. 2, 3, 4, 5, way up here. And 8 is going to be way up at 40. And -1 is going to be down at -5. And -8 is going to be way down at -40, which is hard for me to draw. But that red graph would be the graph of 5 times the cube root of x. Make a note of what happened, what you see. You have stretched the graph vertically away from the x-axis, from the horizontal axis, by a factor of 5. And it distorted the graph quite a bit.